Hello and welcome to part 4 of the video series on buck converter module BUC01. Today we shall look into the experiment for battery charging using the buck converter module. The maximum rating of the lead acid battery which you can charge using this module is 12 volts and 12 ampere hour. Generally, lead acid batteries are charged in 3 stages. First stage is constant current stage. Second is constant voltage stage, and lastly it is float charge stage. In today's experiment we will perform only 2 stages of charging, that is constant voltage and float charge stage. During constant voltage stage, the charging voltage is kept constant at 14.5 volts. As the battery gets charged, the charging current reduces. And once the charging current goes below 5 to 10% of the ampere hour rating of the battery, the float charge stage begins. In this stage, the voltage should be dropped down to 13.5 volts. Here you can see the complete experimental setup. This is the buck converter module. This module is connected to Arduino board. We have a diode connected at the output terminal. This is IN5822 diode with rating of 40 volts and 3 amperes. And for experimental purpose here we have a lead acid battery of 12 volts and 3 ampere hour rating. We also need a 5 ampere range current sensor module ACS712. This is required to measure the battery charging current. A regulated power supply is used to power the module. And before we start the experiment, let us check the initial battery voltage. You can see it is around 12.5 volts. Follow this diagram to make connection between Arduino and module. This is the connection diagram for current sensor and battery. Let us now quickly go through the Arduino program. We start by fixing the switching frequency of buck converter module to 100 kHz. Then we set the voltage to 14.5 volts for constant voltage stage. The charging current is limited to 1 ampere, which is almost 30% of 3 ampere hour rating of the battery we are using today. Next, we set the float charge voltage to 13.5 volts. The float charge current is set to 0.2 amperes. This value is equal to 7% of 3 ampere hour. You can make the necessary changes in these parameters as per your battery ratings. Here digital pin 9 is set to generate PWM signal at 100 kHz. Inside the loop function, we first run this while loop if there is input voltage above 12 volts. Inside the while loop, we increase the output voltage of the buck converter. The program comes out of the while loop if the battery charging current is above the set value of charging current. Also if the output voltage has reached the constant voltage limit. The next important thing is to read the battery charging current. If the charging current is less than the float charge current limit, we try to keep the output voltage at 13.5 volts. In the next situation, if the battery current is greater than floating charge current and less than charging current limit, we adjust the output voltage around 14.5 volts. In case the battery charging current is greater than the charging current limit, we need to reduce the duty cycle value. Now let us upload the program to the Arduino board. We now come back to the experimental setup. And here you can see the readings on the serial monitor. Let us power up the system. You can see the reading of input voltage which is around 18 volts. The duty cycle value starts increasing. As a result, the output voltage is also increasing. As soon as the output voltage reaches 14.5 volts, the program comes out of the while loop and enters the constant voltage stage for charging. The current drawn is around 0.5 amperes. Output voltage is maintained at 14.5 volts. We leave the setup to charge the battery for 20 minutes. Now the charging process has entered into float charge stage. Current drawn is less than 0.2 amperes. The output voltage is now fixed at 13.5 volts. And if we check the battery voltage now, it is around 12.96 volts. And when we started the charging process, the battery voltage was around 12.5 volts. So this is the complete charging process for lead acid batteries. Thank you for watching. Place your order now. Link in description.